Hi. Progress report as of May. As you can see, we've got the milling machine running at the moment. We managed to get all the axes working. Unfortunately, I had problems with interference with the variable frequency drive. It kept bombing out the breakout board with the communication error. So obviously it's a cheap crap VFD, which is kind of annoying. That VFD works fine, but as soon as you start the spindle, it just communication error with the PC just drops out. So in a story, it's no good. So, but drive and axis all working fine. It's just on a little warm-up program at the moment. Just moving all three axes around. So steppers are a good idea to warm up 10 minutes before you start operating. So panels, at least this is up and going. Communicational boards are all working away. You can see the smooth stepper here, which just allows me to drive the whole machine from a USB lead straight off the USB port there. Simple, no parallel port or anything else. So yeah, I'm quite happy with that. Thanks a lot to Steve for finalising the wiring and doing some fault finding with me. That's the 3-stepper drives. No damn spindle control, but kind of everything. She's going. We started to strip down the tool changer chain unit, which all the pockets are missing off of there. Just tried to, with the help of Steve, we've managed to find out some of the I/O from the tool changer electronics. We figured out some of the moves, but it looks we are going to have to run a PLC to interface between the unit itself and the Mac3 control. Otherwise the Mac gets very complicated. It's just easy to get a PLC. We can give it a change tool signal and a binary signal for the tool, which tool we want to change to, and it'll do the work and then send a signal back saying tool change finished. So, machine progress. The car, right, well the car's kind of, looks like it may have taken a step backwards, but it's taken a huge leap forward. Presently looking at a third update on the front suspension. I may, this is the original cast, like you've seen the CAD drawings and stuff of the Corvette bearing tub unit. Is a standard Granada unit. It's just a modified unit to fit Corvette wheels. But I want to change a couple of more things on it. The rack is a little close here, so there's not a huge amount of room for a gaiter. So I'm going to lower the rack 2 inches, give it into a wider space. I've actually got room for a gaiter. It does complicate matters in some respects, but also, let's turn this here down. Just give me options all the way. Okay, roof scoop. You can see at the moment we've butchered the roof. The entry point here, as I said, the new centre section body will have a lowered section in the roof to take advantage, grabbing as much air as possible. Presently see there's a tin plate on the top of these tubes. Well, we're going to take that tin plate and we're going to weld it on the bottom. So now being on the bottom, still does the same structural, still adds the same amount of structure back in, but effectively now we've got an area we can come down. It's easy from the back. Right, you can now see where the tin is. Well, imagine that's 38mm higher than it will be, so we can drop that down 38mm. Now, looking at adding structure to the back here, I can actually notch out this tube here, add structure back in to the bar support here. So basically add structure here, here and here to take what I move out of there, and then we can come directly from where that painted line finishes here, take that height, drop down, and then all that section there becomes an air into the front. Now you can see where the windscreen line finishes here, where the windscreen will fit basically up to that edge. that edge there is actually taller than the tube that's in here. So the highest point of that tube is actually just about the same as that. So we can start the roof scoop, cutting it out down to here and back up to there. So if you look, I can just remove this section because I was using that. You can see between the two tubes we can come down quite a bit, so we should gain air into the air intake without having to lift it too high off the roof. So, which is what I'm quite happy about. Why did I cut this? Well, it will become apparent when effectively you see the top scoop mould. Well, technically this fits on top of there and forms the lip for the return on here. So there's a return lip there, so we can bolt that to the roof. And the roof will technically look something like that, albeit scalloped down, across and up again. So this body section was always going to be sacrificial, but it doesn't take too much doesn't take a huge amount to make a new one when you have a mould. So laying up another one at the moment. That's about as far we go. Steve maybe some nice sort of dummy shock absorbers just for doing ride heights and calcs, so we've got some dummy shocks now. Below, so this and that plate are both going to be redone. Engines lifted about a ½ inch just to give me just that little bit more clearance for the sump. The sump was actually sticking slightly below the bottom of here before, so I'm just going to lift the engine ½ inch just to make sure that I can put an aluminium flat pan underneath here. And I say we're dropping most of these, dropping the most of the suspension points about 12 to 17 millimeters, alter the geometry a tad. Then alter this wishbone here. This is going to come further forward, and we might, instead of picking up on the front point with the wishbone and then putting the towing eye here, we're going to swap that round, so the towing eye will be at the back, the wishbone will be here. Well, that'll give me more room for the push rod, which obviously sits up here, and was getting very close to those two there. So I'm technically just going to move that over and out the way to give me more room. So as you see, you rip it all out and start again. But you have to start from somewhere. The idea of a prototype is purely the fact that you can keep modifying. Anyway, got to shoot. 10 minutes are up. YouTube will be killing me. Okay, speak to you later.